Welcome friends, we are discussing network theory module 6 two-port network. So far we have discussed Z parameter representation and Y parameter representation. Now in this part we shall continue our discussion on remaining two parameters. Let us first discuss the T parameter. Now here T represents or T refers to be transmission, right? T refers to be transmission. It's called transmission parameter. How these parameters are evaluated? It is actually input parameters. That means V1, I1 is represented as a function of output parameters V2 and I2. So if we write V1 is equal to in this way, let us write in this fashion. So we have V1, I1 as our input parameters, and let us have one matrix of 2 by 2. Then we have our matrix of output parameters V2, I2. So in this within this matrix we don't have any one particular type of thing, right? Let them name A, B, C, D. Let them name A, B, C, D. So if you now expand, so V1 is equal to A V2 plus B I2. And similarly, if you expand the second equation, it becomes I1 is equal to C V2 plus D I2. So from these two equations, if we make, let us make I2 is equal to 0. Let us make I2 equal to 0. So what does it mean? So let us make I2 is equal to 0. So immediately what we can write, A is equal to V1 by V2 and C is equal to I1 by V2. So as A is the ratio of two voltage, it does not have any unit. So A having unitless. However, if C is the ratio of current by voltage, so it has a unit of mho. Right? It is a current of unit of mho. Now on the other hand, let us make 0 now, V2 equal to 0 now. So at the first sometime we are making I2 is equal to 0, that means open circuiting output port, and sometime let us make V2 is equal to 0, that means we are short circuiting output port. So it is a mix between both the thing we are doing, open circuiting, short circuiting, both the thing. So now if we make V2 is equal to 0, then B will be equal to V1 by I2. Okay, and D will be equal to I1 by I2. Now these two equation B and D, they are both true only when V2 is equal to 0, and equation of A and C are only true when I2 is equal to 0. Now if you look, B has a ratio of voltage and current, that means it has a unit of ohm. On the other hand, D is a ratio of two current, that means again D is a unitless. So here these things are exactly represented here. A is equal to V1 by V2 with I2 is equal to 0. It is called reverse voltage gain, right? it is actually a ratio of two voltages, but so that is why it is representing a voltage gain definitely. But why reverse? Because it is input by output. It represents input by output. That is why it is called reverse voltage gain. D is equal to I1 by I2 with V2 is equal to 0. So it represents a current gain with reverse term because input by output, right? Now when you consider C, it is I1 by V2. So it again, so I1 by V2, that means input by output, that means reverse transfer admittance, right? Already this meaning of this each term is explained in the previous section. And finally we have V1 is equal to V1 by I2. So again V1 by I2 means input by output, that means signal is flowing from output to input, that is reverse transfer because it involves both the parameter, both the ports 1 and 2, and it impedance. Why? Because it is voltage by current. So to discuss one by one, you see T parameters, that means transmission parameters, are also called ABCD parameters, Now units of, just like unlike Z parameters and admittance parameters, all the units, all the parameters of ABCD or transmission networks or transmission parameters are not same. It is quite evident from the definition of ABCD, right? So what we have observed, A and D are unitless. A and D, these two parameters are unitless. It is A and D are unitless, right? On the other hand, B is having a unit of ohm because it represents voltage by current. So B is having a unit of ohm. Lastly, we have C as a unit of mho because it represents the ratio of current by voltage. So it is representing mho. Now what is the application? It is used in the modeling in the transmission line. Okay, it is modeling in the transmission line of electrical power system. In electrical engineering, we have a transmission line. So it is to model the transmission line, we use these parameters, T parameters or ABCD parameters. Now for this type of network or for this type of parameter, equivalent circuit does not exist because we cannot frame. Okay, we cannot frame, it is not possible. Now another important result is that suppose you have two networks. If you have two networks connected in this fashion, it is called a cascade connection. It is called a cascade connection of the two networks. And suppose network 1 having a transmission parameter T1 and network 2 is having a transmission parameter T2. So the equivalent network having the transmission parameter T equivalent. So what is the relation between T equivalent to the T1, T2? You must multiply them now. T1 into T2. That is the fundamental relation. So if you encounter some networks, two networks are connected in this fashion in cascade, that means output of the network 1 becomes input of the network 2. That is called cascade connection. Output of the network 1 becomes input of the network 2. On the other hand, in case of a series network, in case of a series connection, you see if current I1 is entering to this input node, this current should flow through this. This is also I1 and it is closing the circuit in this fashion. So through the input port that current will be flowing I1, and similarly I2 is flowing through the output port. That is why it is called series connection. Now this is called cascade connection because output of network 1 this is output of the network 1, that becomes input of the network 2. That is why it is called series connection. It is called a cascade connection. So if you encounter two networks connected in this fashion, T1 and T2, that means network 1 has having transmission network T1, network 2 having a transmission parameter T2. So equivalent network is product of T1 and T2. So that is a very important relation. We must remember this. We shall use these results or use these formulas in near future to solve different types of problems. Now let us have the final parameter, which is called hybrid parameter. H here stands for hybrid. Why hybrid? Because we have, as already mentioned or as already discussed in the previous section, that we have done some mix and match. We have done some mixing. That means V1, that means input port voltage and output port current is taken as dependent parameter, and independent parameters are, it is input current and output voltage. So in this way we have done some mixing. That is why we see for the independent case we have both input and output variables, and in the dependent case we have both input and output variables. So we have done some hybridization. And that is why it is called hybrid parameters. So fundamental equation is in this way. Same thing can be written. V1 is equal to H11 I1 plus H12 V2. Similarly, second equation we have I2 is equal to H21 I1 plus H22 V2. Right? So how to define them? So we should apply same logic. So first let us make V2 is equal to 0. That means we are making short circuit output port. Right? Because V2 represents the output parameters. So when you make V2 is equal to 0, it immediately refers H11 is equal to V1 by I1. With V2 is equal to 0, and H21 is equal to I2 by I1. So this H11 and H21, it's only true when V2 only becomes 0. If V2 has some non-zero value, then this two equation does not hold. Right? Now let us make I1 is equal to 0. That means we are making open circuit the input port. So with that, what is the H12? H12 becomes V1 by V2. And we have H22 becomes I2 by V2. So we have this definition. So H11, as you can see, it is the ratio of voltage and current. So it is having an impedance ohm unit. H22 is the ratio of two current. So it is a unitless. Right? It is a unitless. Similarly, H12 will be unitless. And H22 will be unit of mho. Right? So H11 is V1 by I1 with V2 is equal to 0. H21 is equal to I2 by I1 with I1 is equal to 0. H12 will be V1 by V2 with I1 is equal to 0, and H22 will be I2 by V2 with I1 is equal to 0. So these are the definition. So V1 by I1, it is called driving input impedance. H22 I2 by V2, it is called driving output admittance. I2 by I1, now this time it is called forward current gain, because I2 by I1, now in the numerator we have output port, so that is why it is forward current gain. And V1 by V2, it is called reverse voltage gain. These are the definitions of H parameters. Now H parameters are called hybrid parameters. Now unit is already mentioned. Now what is the application area of the hybrid parameter? It is used in the transistor modeling. Okay, it is used in the transistor modeling in the analog electronics class or course. You will find transistor BJT. There you will find the application of this hybrid parameter. Now equivalent circuit, if you recall the equations, V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. So as far as this is concerned, H12 V2, it is a voltage is represented by a dependent source. Why? Because it is a voltage of input side but dependent on V2, that means output port. That is why it is represented by a dependent source. In the same way, H22 V2, sorry, no, not H22 V2 now. H21 I1, H21 I1. Because this current I2 has a component of H21 I1 which is dependent on input side current, so that is why it is represented by a dependent source, right? Now V1 has, as far as this parameter is concerned, it is having a voltage V1 input port which is injecting some current I1, and it is flowing through a ohm, or it is flowing through an impedance which is called I11. So that is why H11 I1 drop appears, and H11 I1 drop along with this H12 V2 voltage source makes the total input voltage V1. That is the meaning of this first equation. And similarly, the second equation is output port. We have a voltage V2. We have a voltage V2 that is injecting some current I2. So that current is getting two paths. One path is H2 to V2. So this is actually represented by this admittance. This is mho, and this is this component, that is dependent current source, which is H21 I1. Now just before going into some mathematical exposure, let us quickly, let me tell you one thing, that let us have the, what is the definition of H11? See, H11 is equal to V1 by I1, right? However, if you go back to the Z parameters, Z11 is also V1 by I1. Now the question comes whether H11 and Z11 are the same or different, because both the parameters are representing voltage by current. Both the parameters is actually V1 by I1, so it is the same thing. So the question comes whether H11 equals to Z11, whether they are same or different. The answer is they are totally different. There is no relation. Of course, there is a relation between them, but they are not the same. Why? Because H11 is equal to V1 by I1, it is only true with V2 is equal to 0. With V2 is equal to 0. And Z11 is equal to V1 by I1, this is only true with I2 is equal to 0. So one thing you are getting by making short circuiting, and Z11 you are getting by making open circuiting it. So if you make for any network, if you are making open circuit or if you are making short circuit, both the things are not same. So although they are V1 by I1, but the conditions based on which they are obtained, it's not same. That is why H11 and Z11 are totally different. Okay, they are not same at all. They are not same. So please keep this in mind. Now let us quickly explore one mathematical example. Now let us say we have a figure 10. We have solved this type of problem previously. Let us evaluate Z parameters and Y parameters of this figure 10, right? Z parameters and Y parameters of this figure 10. Now how to solve? Let us find out that this part actually, this 5 ohm, this 1 ohm and this 2 ohm. Okay, so it is actually by these three resistances they form a pi network. They forming a pi network. Let me name them. This is node X, this is node Y, and let me use this is as node Z. So if we make this equivalent conversion, this node is 1, so let us have 2 ohm. So this node is X. So we have a resistance. Now we need to convert this to an equivalent T form or Y. So we can convert this type of thing. This is Z actually, and this new point becomes the neutral point N. So we can convert this equivalent pi to equivalent T. So you need to evaluate each of them individually. So let us recall the formula. Let us recall the formula. Rxn so you need to find out Rx, that is X is common between these two, 5 ohm and 1 ohm, that means Rxy into Rxz and divided by summation of all three, Rxy plus Ryz plus Rxz. So Rxy is how much? 5 ohm. Rxz is how much? Xz is 1 ohm. In the denominator, summation of all these three, that means 5 plus 1 plus Rxy is 5, Ryz is 2 and Rxz is 1. So it will become 5 by 8 ohm. 5 by 8 ohm. So Rxn, this resistance is nothing but 5 by 8 ohm. Similarly, if you evaluate Ryn, So it will be R y x y into R y z divided by summation of all these three. So it will become 5 plus 2 plus 1. So Rxy is nothing but 5. Ryz is nothing but 2. So 10 by 8. So that means it will be 5 by 4 ohm. So this resistance is nothing but 5 by 4 ohm. And last is remaining Rzn. So similarly we can write Rxz into Ryz divided by 8. So Rxz is nothing but Rxz is 1 and Ryz is 2. So 1 into 2 by 8. So it will be 1 by 4 ohm. So this resistance is nothing but 1 by 4 ohm. So once you have done this, now you can see, once you have done this, you can see very interesting thing. Now this 2 ohm and this 5 by 8 ohm are in series. This 2 ohm and 5 by 8 ohm are in series. That is why they are connected in series to make 21 by 8. Right. So how this 21 by 8 comes? 21 by 8 is nothing but 2 plus 5 by 8, which is 16 plus 5 by 8, which is equal to 21 by 8. Right. Similarly, this 5 by 4 plus 2, 5 by 4 plus 2 are in series. So if you add them, 2 plus 5 by 4, you will get plus 5 by 4, you will get 8, 13 by 4. So 26 by 8 and 13 by 4 all are same. 26 by 8 and 13 by 4 all are same. And here it is 1 by 4, so it will be 2 by 8, right? 2 by 8 or 1 by 4, it is all same. So using this formula that is discussed in case of a Z parameter. Now what is the Z parameter? Now you see the application of this rule, right? You see the application of this rule. You will find a T network. Now you can directly write the Z parameters of this T network, right? So what is Z11? Z11 is equal to Z1 plus Z3. That means this 21 by 8 plus 2 by 8. 21 by 8 plus 2 by 8, which is equal to 23 by 8. That is Z11. What is Z22? Z22 is nothing but 13 by 4 or 26 by 8 plus 2 by 8. 26 by 8 plus 2 by 8, which is 28 by 8, or it is 7 by 4 ohm. And finally, we have Z12, Z21 will be equal to 2 by 4, or it is equal to 1 by 4 ohm. So in this way, quite easily we can directly write the result. If you encounter a T network of this kind, right, we can directly get the Z parameters out of this network. Now from figure 10a, you need another conversion. So from T to delta. From T to delta, right? So let us solve that. From T to delta, so let us do that. So what will be R12? What will be R12? Let us use R12. What is the formula? R1 plus R2 plus R1 R2 by R3. That is the formula. Now what is R1 here? R1 here is 21 by 8. What is R2? R2 here is 26 by 8 plus, now R1 R2, that means 21 by into 26 by 8 into 8, and in the denominator we have R3, which is 2 by 8. So if you solve, the first two term will yield 47 by 8, and the second one will yield, you see 1 8 1 8 cancels out, 1 2 and 26 makes it 13. So 21 into 13, that means 73 by 8. So actually it will be 320 by 8, which is equal to 40 ohm, which is equal to 40 ohm. That is R12. So R12 is solved. Now next is R13. R13 relation is R1 plus R3 plus R1 R3 by R2. So what is R1? R1 is equal to 21 by 8. Right? R1 is equal to 21 by 8. What is R3? R3 is equal to 2 by 8 plus 21 by 8 into 2 by 8 by, what is R2? R2 here is 26 by 8. So if you solve this, the first two term will give you 23 by 8, and the third term 1 8 1 8 cancels, so it will be 13 in the denominator, so it will be 21 by 13 into 8, that means 104. So 104 is LCM, so it will be 23 into 13. 23 into 13 plus 21. So altogether it will become 320 by 104. So it will be 40 by 13. 40 by 13 ohm. (40 by 13 ohm) or 40 by 13 ohm, right? So this is one, R12 40 ohm, R13 will be 40 by 13 ohm, and if you consider and if you solve the remaining one, R23, so it will be R2 plus R3 plus R2 R3 by R1. So what is R2? R2 we have 26 by 8, I think. Yeah, 26 by 8, R2 26 by 8 plus, what is R3? R3 is equal to 2 by 8 plus 26 into 2, that means 52 by 8 into 8 divided by R1. What is R1? R1 is nothing but 21 by 8. 21/8. So if you solve, the first two terms will give you 28/8 plus the second two terms 18 cancels, so 52/168. So 168 becomes the LCM. So it will be 28 into 21 plus 52. So it will become 640 by 168. So it will come around 80/21. 80/21 ohm. So these three values, right? These three values. Now we have got a delta network with these three values. Now let us go back and explore that rule. So you have, when you have the pi network ready for you, this one, when you have a pi network is ready for you, then you can directly write this formula, provided one condition: these are represented in admittance. These are represented in admittance form. So let us convert these resistances into admittance form. So you see, this R12 is represented as 1/40 mho. That is the reason. It is 40 ohm. So the same thing can be written as 1/40 mho. R13, it is written, I think, yes, 40/13. So it will be, it is 21/80. It is 23 or 22 dash. It is right. It is 80/21 came. So it will be 21/80, but it is not, somehow it is matching. It is 27/80. It is actually there is some, maybe some calculation error. Okay, so if it is at a 27/80, so let me check one second. R1 is equal to 21/8. R2 is equal to 2/8, 21/8 into 2/8 by 26/8, that is okay. First two term will give you 23/8, that is all right. 18 cancels, 2 and 13 into, okay, 21/104 to 23 into 13. 23 into 13, 299 plus 21, so it will be 320, right? 320/104. So if you cancel both the numerators and the denominators by 8, so numerator become 40 and the denominator becomes 40/30. So it is 40/30. So it must be, it is not 27/80. It should be, according to this calculation, 13/40 mho. 13/40 mho, right? So you can directly now write what is Y11. Y11 is equal to, it is right, it is 1/40 plus 13/40. So it will be 14/40 or 7/20 mho. That is Y11. What is Y22? Y22 is equal to 1/40 plus 21/80. So it will be 23/80. Right, this is all right. And Y12 and Y22, it is not 1 minus 1, yes, sorry, y12 and y21, that will be minus of minus 1 by 40, so it will be minus 1 by 40. So if you in gist, if you have this and this network, so its equivalent Z parameter, if a network is given like this, its equivalent Z parameters is evaluated as this 23 by 8, 23 by 8, Z12 is 1 by 4, Z21 is also 1 by 4, and Z22 is 7 by 4. And the same network, if Y parameters are represented, so Y parameters are represented by Y11 will be 7 by 20, 7 by 20, Y12 and Y21 will be same, that is minus 1 by 40, minus 1 by 40, both Y12 and Y21, and Y22 will be 23 by 80. All are in mho, and they are all are in ohm. So it's the same network. These are the two different representation. One is represented by Z network, Z parameter, and another one is represented by Y network or Y representation. So with this, I am ending this part. We have defined the 4 parameters, and we have seen different nomenclature, and we have also solved one problem by converting Y network to delta network and delta network to Y network, and we have effectively utilized the rule of how to write Z parameters for a T networks and how to write Y parameters for a delta network. So with this, I am ending this part. We shall see more problems with more aspects of two-port networks in the next few sessions. Thank you.